This video is going to review how to solve radical equations. So a radical equation, our goal is going to be to get rid of that radical. And in order to do that, our radical needs to be isolated. So let's take a look at our first example. The square root of 2x minus 4 plus 2 equals x. So what I want to do is get that square root alone. So my first step, I'm going to subtract 2 on both sides. So I get the square root of 2x minus 4 equals x minus 2. And now that the square root is alone, we can raise both sides to the second power. So on the left, when I have a square root and a square, they're going to cancel each other out, and I'm going to be left over with this 2x minus 4. And on the right side, I have x minus 2 squared. So here, I'm going to have to use the box method or double distribute in order to find out what x minus 2 squared is. So on the side, I'll just draw out my box method. I'm going to get x squared minus 2x minus 2x and a positive 4. So when I go back to my equation over here, I'm going to have x squared minus 4x because I grouped these two pieces together plus 4. Now, whenever we have an x squared, we always want to set it equal to 0. So I'm going to take the left side and bring it over to the right side. So I'm going to subtract 2x on both sides. And in the same step, I'm going to add 4 to both sides. So my left side is going to cancel to be a 0. On my right side, when I combine like terms, I'm going to get x squared minus 6x plus 8. And now whenever we have an x squared set equal to 0, we want to factor. So it's a trinomial. I'm going to have two parentheses. An x goes in each parentheses. I'm going to bring down this negative. A negative times a positive is a negative, and I'm looking for the factors of 8. That will give me 6. So it's going to be 4 and 2. Then after we have our factors, we tee off. I'm going to get x equals 4 and x equals 2. But once we have our answers for a radical equation, we always have to go back and check. And there's a few ways you can check. The first way is you can take your answers of x equals 4 and x equals 2 and substitute in to the original equation. So I'll show you that way. So if I have my original equation is the square root of 2x minus 4 plus 2 equals x. And I want to check to see if x equals 4 works. So anywhere I see an x, I'm going to put in a 4. And I want to see if this is true or false. So in my calculator, I'm going to type in that left side of the equation. So I have my calculator. I'm going to go to my home screen. I'm going to type in the square root of 2 times 4 minus 4. I'm going to hit the right arrow to get outside the radical, plus 2, and I'm going to get 4. So the left side of my equation is 4. So I get 4 equals 4, so I know it checks. So that's one way to check. And then I could also plug in and do the same thing with my x equals 2. But I want to show you the second way to check. And this way is actually probably going to be a little bit easier for you. So what we're going to do is we're going to go back to our original, and I'm going to take the left side and I'm going to put it in y1 in my calculator. And I'm going to take the right side and I'm going to put it in y2 in my calculator. So I'm going to go back. This time I'm going to go to the y equals. In y1, I'm putting in the square root of 2x minus 4. I'm going to hit the right arrow to come outside the radical, plus 2. That was the left side. And now the right side, I'm going to put in y2. So those are your two equations. So now I'm going to go to my graph first. And we're going to take a look at our graph. And I'm actually going to take this graph and I'm going to bring it onto our picture for us. so we can talk about it in a minute. The other thing I want to look at is the table. So second graph, I'm going to go to the table. I'm going to scroll down a little bit so we have a better table. And I'm going to click and drag this so you can be looking at them on your calculator and on my screen as well. So if we take a look at our graph, it's kind of hard to tell in this one, but if you notice, the graph intersect at two different points. So we know that both of these work because I have 2 points of intersection, so both x values work. The other thing you want to look at is your table, and that might be easier in this one because the graph was kind of difficult to see. So for my table, I'm going to x equals 4, and I want to see that my y values match. They're both the same, so I know it works. And I also want to go to x equals 2. They're both the same, so I know it works. So no matter which way you check, you should always get the same answer. Both of these solutions work. If one of them didn't work, we would reject that answer. Okay? Let's take a look at one more question. So here's our next question. The square root of 2x plus 1 equals x minus 1. Now, once again, you always want to isolate that radical so you can square both sides. In this case, it's nice and set up for us because I can go right to squaring both sides. The radical is alone. And remember, that squared and that square root cancel out. So on the left side, I am left with just 2x plus 1. On the right side, x minus 1 squared, we need to either use the box method or double distribute. Since I did the box method in the last problem, I'll double distribute in this one. So this is my scrap work on the side, and now I'm going to substitute it back in to my equation. So we have 2x plus 1 equals x squared minus 2x plus 1. So now I have an x squared. I know I have to set it equal to 0. So I'm going to subtract 2x on both sides and subtract 1. On the left side, we're going to get 0. On the right side, I'm going to get x squared minus 4x. Once we have an x squared set equal to 0, we're going to factor. This has a GCF of x, and I'm left with x minus 4. So I have x equals 0 and x equals 4 when I tee off. But remember, you always have to go back and check your answer. We have 3 ways to check it. You can substitute, you can go to your table or your graph. I'm going to do the table and the graph right now. So I'm going to go back to my calculator. In y1, I'm going to clear out what I have there, and I'm going to put in the square root of 2x plus 1. And in my y2, I'm going to put in x plus 1. Oops, nope, x minus 1. Good thing I checked that. So x minus 1. So now I'm just going to click and drag this so we can see what we're talking about. Here's my y1 and my y2. Let's go to my graph. I'm going to click and drag this so we can talk about that. Nope. Okay, and lastly, I'm going to hit second graph to go to my table. You guys can obviously look at these things separately, but I want to bring them all together so that we're on the same page. This one came in super big, so let me just make this a little bit smaller. Okay, so I have my y equals, I have my graph, and I have my table. So if we're looking at our graph, if you notice, the graphs only touch at one point, and that point is x equals 4. So this x equals 4 works. We're actually going to reject that x equals 0. It doesn't work. And if I look at my table, I'm looking at x equals 0 and x equals 4. At x equals 0, my y values don't match. I have a 1 and a negative 1. but at x equals 4, my y values are both 3. So the answer to this radical equation is just x equals 4. You have to reject the x equals 0. So remember, radical equations, you want to isolate the radical, square both sides. Once you solve, make sure you check your answers.